SpaceX just confirmed its biggest milestone yet, orbital insertion on Flight 14. Sounds exciting, right? Except there's a catch nobody's talking about. Flight 12 left several Raptor engines damaged. If Flight 13 doesn't fix that problem, Flight 14 might not happen at all. Here's the full story. Let's start with the problem everyone wants to skip past. Flight 12 was supposed to be the flight that finally proved Starship was ready for anything. And in a lot of ways, it was. SpaceX successfully relit a Raptor engine while Starship was coasting through space, something that had never been done on this vehicle before. That single achievement is the reason orbital flight is even on the table for Flight 14. Without it, none of this conversation happens. But here's the part that got buried under the celebration. Several of the Raptor Vacuum engines, the ones built specifically to fire in the vacuum of space, ran into trouble during the flight. To understand why that matters, you need to know that Starship's engines aren't all identical. The engines on the booster and some on Starship itself are sea-level engines, built with smaller nozzles designed to work where Earth's atmosphere pushes back against the exhaust. The Raptor vacuum engines have enormous wide-flared nozzles built for the opposite environment, zero outside pressure. Run a vacuum-optimized engine in the wrong conditions, even briefly, and it behaves differently than it's designed to. Getting that nozzle geometry, that ignition sequence, and that relight reliability right every time is one of the genuinely hardest problems in the entire Starship program. And it's not a side problem. It's the problem. Every mission to the Moon or Mars requires Starship to coast through deep space for days, then relight its engines on command, with zero chance for a do-over. If the Raptor vacuum engines can't be trusted to do that reliably, the lunar lander doesn't work. The Mars cargo ship doesn't work. Orbital refueling doesn't work. It all traces back to this one engine. So when you hear that Flight 13 is just another suborbital test, understand what that really means. It's not a step backward. It's SpaceX saying, this is the one thing we are not willing to get wrong twice. Flight 13, the flight that has to be boring. Notice the exact words Gwynne Shotwell used. She didn't call Flight 13 the orbital flight. She called it another suborbital shot. That phrasing is doing a lot of work, and it tells you everything about SpaceX's mindset right now. A lot of fans were hoping Flight 13 would be the big one. Full orbit, payload deployment, all of it. Shotwell shut that down, gently but clearly. Flight 13 has exactly one job: prove that the engine fixes from Flight 12 actually work under real flight conditions before anything else gets risked on top of them. Here's what that looks like on the ground, right now, before Starship and its super heavy booster, known for this mission as S-40 and B-20, ever reach the pad. First, static fires, briefly igniting the engines while the rocket is still bolted to the ground to confirm they light correctly and produce the thrust they're supposed to. Then, engine inspections, teams physically checking for the exact kind of wear that caused trouble on Flight 12. And finally, a wet dress rehearsal, loading the rocket with hundreds of tons of supercooled propellant and running through the entire countdown, right up to the final moment, without actually lifting off. Each one of those steps exists to catch a problem on the ground instead of in flight. And that's exactly why a June launch was never realistic, no matter how much the community wanted it. Shotwell's own phrase, a month-ish away, points toward early to mid-July at the earliest, and that timeline isn't bad news. A rushed Flight 13 with unresolved engine concerns would be the worst possible outcome for this flight and for the orbital attempt riding on its success. There's also a quieter story in this flight that doesn't get talked about enough. This is one of the first flights of the V3 Starship design. Larger propellant tanks for more range, and a newer generation of Raptor engines built with significantly fewer individual parts than before. Fewer parts generally means fewer failure points. If Flight 13 goes well, it's not just proof that the specific engine issue from Flight 12 got fixed. It's proof that the new hardware generation itself is fundamentally more reliable. Flight 13, in other words, isn't the appetizer. It's the foundation everything else gets built on. Here's something worth sitting with. Officially, the story is simple. Fix the engines, fly again, prove it worked, But talk to enough people who follow this program closely, and you'll hear at least two different theories about what's really driving SpaceX's caution right now. And they don't fully agree with each other. Theory 1 is the one we've already covered. Engine reliability, plain and simple. Fix the Raptor Vacuum relight issue, validate it in flight, move on. Theory 2 points somewhere else entirely, the heat shield. Every Starship flight pushes the thermal protection tiles closer to the conditions of a real orbital re-entry, which is dramatically hotter than anything a suborbital hop produces. Some analysts argue that even if the engines were perfect tomorrow, SpaceX still wouldn't risk a full orbital attempt until the heat shield has been tested against re-entry heating that's closer to the real thing. Because an orbital re-entry failure, with a vehicle moving that fast, is a far bigger loss than a suborbital one. Which theory is right? Possibly both. SpaceX rarely explains its full reasoning in public, and "we want to fix the engines" is a much simpler headline than "we want to fix the engines, validate the heat shield under higher energy conditions, and confirm the V3 structural changes all at once." But here's the detail worth watching for when Flight 13 actually flies. Pay attention, not just to whether the engines relight successfully, but to how SpaceX talks about the heat shield's performance afterward. If that gets unusually detailed coverage, Theory 2 just got a lot more credible. What orbital insertion actually means and why it changes everything. Now to the headline. Flight 14, according to Shotwell, is when SpaceX hopes to attempt orbital insertion for the first time. But what does that phrase actually mean, and why is it such an enormous leap from everything Starship has already done? Picture throwing a ball, throw it hard, and it arcs through the air before gravity pulls it back down. That's essentially what every Starship flight so far has done, including the successful ones. An enormous, controlled arc that ends with a landing. That's suborbital. Now picture throwing that same ball so hard and so precisely that by the time gravity pulls it back toward the ground, the curve of the Earth has already dropped away beneath it. The ball never lands. It just keeps falling around the planet, forever. That's orbit. It's not about altitude. It's about speed and direction. Going fast enough, in exactly the right line, that the ground keeps curving away as quickly as you're falling toward it. That distinction sounds abstract, but it's the difference between an incredibly impressive flight test and a vehicle that can do useful work in space. Once Starship reaches orbit, an entire list of capabilities unlocks for the first time. Real payload deployment, satellites, cargo, eventually crewed vehicles. Re-entry testing from orbital velocity, which generates dramatically more heat than anything a suborbital flight produces. And the capability that matters most for SpaceX's biggest goals. Orbital propellant transfer. One Starship pumping fuel into another Starship, while both are in orbit. Why does that one capability carry so much weight? Because NASA's Artemis program depends on it directly. The Starship variant assigned to land astronauts on the lunar surface has to be fully refueled in orbit before it can make the trip to the moon. Without successful propellant transfer, that mission doesn't happen. Not on the current timeline, not with the current vehicle. So when this gets called a milestone, understand the scale of what that word is covering. It's not just a SpaceX achievement. It's a NASA achievement. It's the thing a huge portion of the next decade of lunar exploration is quietly waiting on. And that's exactly why Flight 13 is being treated with this much care. You don't take shortcuts on the flight before the most consequential flight in the program's history. The gate that has nothing to do with the rocket. Here's something almost no coverage of this story mentions, and it might be the single biggest factor in whether any of this actually happens on schedule. And it has nothing to do with engines, heat shields, or anything SpaceX builds with its own hands. In that same interview, Shotwell didn't just say she hopes Flight 14 attempts orbital insertion. She also said it largely depends on the FAA. That's not a throwaway line. That's the actual gate. Here's why it matters. Every Starship flight needs a launch license from the Federal Aviation Administration, and that license doesn't just cover liftoff. It covers the entire flight profile, where the vehicle is allowed to fly, what airspace gets closed below it, and, for an orbital attempt specifically, where and how it's allowed to come back down. A suborbital hop that splashes down in a pre-cleared corridor is a known, already approved profile. An orbital flight is a different profile entirely. A different ground track, different re-entry zones, potentially different countries underneath that flight path. That doesn't get approved automatically just because the rocket is ready. Put plainly, SpaceX could have the most reliable Raptor engines ever built, a heat shield that's been validated from every angle, and a Flight 13 that goes perfectly. And Flight 14 still doesn't fly as an orbital attempt unless the FAA has separately signed off on that specific flight profile in advance. This is also exactly why this video's title says revealed, not guaranteed. What SpaceX revealed is the plan, the intent, the sequencing, the engineering target. Whether Flight 14 actually executes that plan depends on a second process running in parallel, one that SpaceX doesn't fully control. Paperwork, environmental review, and a regulatory green light. And that flips the framing of this entire story. The most uncertain part of Starship reaches orbit on Flight 14 might not be whether the rocket is ready. It might be whether the rocket is allowed to. The twist, Starship might fly from Florida next. Here's where things take a turn nobody saw coming. In that same conversation, almost as an afterthought, Shotwell mentioned that Flight 15 might launch from the Cape Canaveral, Florida, not Starbase in Texas, where every Starship flight to date has launched from. On the surface, that sounds like a logistics footnote. It isn't. For years, SpaceX has quietly been building Starship infrastructure on Florida's coast, modifying launch pads, constructing massive new assembly buildings, laying the groundwork for a second full Starship launch site, roughly 1,500 miles from Starbase. And now, for the first time, there's an actual flight number attached to it. So here's the question worth sitting with. If Flight 13 and Flight 14 are this high stakes, if one of them has to nail engine reliability and the other has to do something Starship has never done before, why is SpaceX already talking about a third launch location coming online just one flight later? There are two ways to read that. The simple read is that it's just SpaceX being SpaceX, talking about the future the way it always does, regardless of how the next two flights go. But there's a more interesting read. You don't build a second orbital launch site in a few weeks. Whatever's happening in Florida right now has likely been under construction for a long time, running in parallel with everything happening in Texas. Which means this isn't a reaction to Flight 13 or 14 going well. It's a bet that was placed a long time ago. A bet that Starship would eventually need two coasts to fly from, if a monthly cadence is ever going to be real. And that's the actual twist. This isn't just about whether one rocket reaches orbit. It's about building the infrastructure for an entire fleet of rockets to launch from two coasts, potentially at the same time. If Texas needs downtime, Florida keeps flying. If Florida needs downtime, Texas keeps flying. That's not a backup plan. That's a production line for orbital-class rockets, something that has never existed in the history of spaceflight. And remember the gate from a moment ago? It applies here too, twice over. Flight 15 launching from Florida isn't only a hardware and pad readiness question, it's a separate FAA licensing process for a second site, one that has to be reviewed and approved on its own, independent of whatever happens in Texas. Two coasts don't just mean two launch pads. They mean two regulatory files moving through the same agency at the same time. Why monthly changes the entire timeline? Let's zoom out because there's a number buried in all of this that's easy to miss. Monthly. Shotwell didn't just talk about Flight 13. She said that afterward, SpaceX should be flying every month. To see why that matters, compare it to where things stand now. Starship flights have been running roughly 2 months apart, sometimes longer, especially after a flight that needed a full investigation, like the one before Flight 12. Cutting that gap in half doesn't just mean twice as many rockets. It means twice as much flight data, twice as many chances to test heat shield tiles under real conditions, twice as many chances to validate engine relights, twice as many opportunities to catch the next problem before it becomes a mission-ending one. This is where SpaceX's entire approach diverges from how rockets have traditionally been developed. The old model: design something, analyze it for years, build very few of them, and treat every launch as something almost too precious to risk. SpaceX's model looks a lot more like how software gets built. Ship something, see what breaks, fix it, ship the next version, repeat. Even the flights with problems generate the data the next iteration needs. Looked at that way, the Raptor Vacuum issue from Flight 12 isn't really a setback at all. Those engines didn't fail in the dark. They failed during a flight packed with sensors, cameras, and telemetry. SpaceX now knows exactly what went wrong, under real flight conditions, in a way that years of additional ground testing could never replicate on its own. Flight 13 exists to apply that lesson. If it works, it proves something bigger than the fix worked. It proves the entire loop. Problem, data, fix, validation, runs at the speed SpaceX actually needs. And that loop is the real foundation underneath everything in this story. Monthly launches, orbital insertion on Flight 14, a second launch site for Flight 15. None of those are separate goals. They're all downstream of the same question. Can Starship's engines, heat shield, and overall systems hold up to flying again and again fast without starting from scratch each time? There's a version of this question for the FAA too. A monthly cadence doesn't just require SpaceX to be ready every month. It requires the licensing and review process to keep pace with SpaceX, flight after flight, without becoming the bottleneck itself. If the rocket gets faster than the paperwork is what determines the real cadence, not the hardware. 4 things to watch for on Flight 13. Before we get to what happens next, here's exactly what to look for when Flight 13 actually launches. Because these 4 details will tell you more than any headline will. First, how SpaceX describes the Raptor Vacuum performance afterward. If the language is specific, mentioning relight timing, chamber pressure, or burn duration, that's a strong signal the engine fix is confirmed. Vague language, on the other hand, might mean the picture is more complicated than expected. Second, how much attention the heat shield gets in post-flight commentary. Remember Theory 2 from earlier. If thermal protection suddenly becomes a major talking point, that tells you it was a bigger factor in the timeline than officially stated. Third, timing. If Flight 13 launches close to the early July window Shotwell hinted at, that's a good sign the testing checklist, static fires, inspections, wet dress rehearsal, went smoothly with no major surprises. If it slips into late July or beyond, something on that checklist found a problem worth solving before flight. Fourth, and this is the one most people will miss, any mention of an FAA launch license update, an environmental review, or a regulatory approval tied to orbital flight or the Florida site. That kind of paperwork rarely makes headlines on its own. But if it moves forward quietly in the background around the same time as Flight 13, that's one of the clearest signs that the plan in this video is turning from a hope into a green light. 2 flights stand between SpaceX and an orbit-capable Starship. One has to prove the engines are fixed. The other has to do something this vehicle has never done before. And running underneath both of them the entire time is a regulatory process that neither flight controls. Depending on how all 3 of those play out, the rest of this year could look completely different than anyone's currently expecting. That's the full case for Flight 14. The engines, the heat shield, and the paperwork. Thanks for working through it with us. Like, share, comment, and subscribe to the Space Brief. Tap the screen for more.